Automation in hydraulic press. Enhancing efficiency and precision. Automation in hydraulic press systems has become increasingly vital in modern manufacturing, as industries demand higher productivity, precision, and cost-effectiveness. Traditionally, hydraulic presses relied on manual operation, but automation has revolutionized their functionality by integrating advanced control systems, sensors, and robotic technologies. This shift allows manufacturers to achieve enhanced efficiency, consistent quality, and improved safety. Key benefits of automation in hydraulic press. Increased precision and repeatability. Automation enables hydraulic presses to perform complex tasks with high accuracy. Automated systems control parameters such as pressure, speed, and positioning with tight tolerances, ensuring that every cycle produces parts with consistent dimensions and quality. This is critical in industries like automotive, aerospace, and electronics, where precision is paramount. Enhanced productivity. By automating the entire press operation, manufacturers can significantly reduce cycle times and increase production throughput. Automated hydraulic presses can operate continuously with minimal downtime, as robotic systems handle material loading, unloading, and part inspection. This eliminates bottlenecks and increases overall efficiency. Improved safety. Automation minimizes human intervention in hazardous tasks, reducing the risk of accidents. Operators no longer need to manually load and unload parts or control press cycles, as these functions are performed by automated systems. Safety interlocks, sensors, and emergency stop mechanisms further enhance operator protection. Energy efficiency. Modern automated hydraulic presses often include intelligent energy management systems that optimize power consumption. Automated controls ensure that the press only uses the required energy for each task, reducing waste and operational costs. This aligns with the broader industrial goal of sustainable manufacturing. Data monitoring and analytics. Automation systems can be integrated with data collection tools, providing real-time monitoring of the press's performance. Parameters like pressure, temperature, and cycle time are tracked, allowing manufacturers to identify potential issues, optimize processes, and perform predictive maintenance. This reduces downtime and prolongs the life of the equipment. Customizable and flexible operations. Automated hydraulic presses can be programmed for a wide range of applications, from simple forming and stamping to complex multi-step operations. With easy reconfiguration, the press can handle different materials, part sizes, and production volumes without requiring significant manual adjustments. Applications of automated hydraulic presses. Automated hydraulic presses are used across various industries, such as automotive, for forming, stamping, and assembling components like body panels, transmissions, and engine parts. Aerospace, to manufacture lightweight, high-strength parts that meet strict performance and safety standards. Electronics, in the production of connectors, switches, and other small precision components. Automation in hydraulic presses is a transformative development that boosts productivity, ensures precision, and enhances safety. By integrating Industry 4.0 technologies, such as sensors and data analytics, automated hydraulic presses enable manufacturers to meet the high demands of today's industrial landscape, while reducing operational costs and energy consumption. This trend is set to further advance as the industry continues to innovate and embrace smart manufacturing practices. Automation in hydraulic press for automotive applications. Oil plug, oil seal, impeller shaft, and water seal pressing. In the automotive industry, precision and consistency are crucial for ensuring the performance and reliability of components. Processes such as oil plug pressing, oil seal pressing, impeller shaft pressing, and water seal pressing involve high accuracy and force, making hydraulic presses the ideal equipment for these applications. Automation of hydraulic presses in these processes not only improves productivity but also ensures consistency and traceability, which are essential for automotive standards. Below are the key automation features for these applications. Individual display on each press. Each hydraulic press is equipped with its own dedicated display, allowing operators to monitor specific parameters such as force, displacement, and cycle time in real time. This ensures better control over the pressing operation and improves process visibility for individual tasks like oil plug pressing or water seal insertion. Load cell for individual force measurement. Each press includes a load cell that measures the pressing force applied to each part. This feature ensures that the correct force is applied, which is critical for delicate operations like oil seal pressing and impeller shaft assembly. Accurate force measurement guarantees the parts are neither overpressed nor underpressed, maintaining component integrity and performance. Common LVDT, linear variable differential transformer. For displacement measurement, a common LVDT system measures the displacement or movement of the press. This feature is important for monitoring the precise movement required in tasks such as oil plug or shaft pressing, where accurate positioning directly affects the functionality of the final assembly. Display for graph plotting and data storage. The display is integrated with software that plots graphs for load versus displacement, providing a clear visual representation of each press cycle. The data is stored for quality control, traceability, and further analysis. This is especially useful in high-precision processes like oil seal or water seal pressing, where deviations in load or displacement can indicate defects. PLC communication. Each hydraulic press communicates with a programmable logic controller, PLC, to coordinate the pressing operation and ensure proper sequencing. This integration is essential for automating multiple presses simultaneously and managing complex tasks like impeller shaft pressing in an assembly line. Separate display for load cell graph with backend software. Each load cell has a dedicated display to show a load versus displacement graph, which is accessible through the backend software. This allows operators to closely monitor the pressing process, ensuring that force and displacement remain within predefined limits for components like oil seals or shafts. Result communication with machine PLC. The result from the load cell and LVDT sensors, including force and displacement data, is communicated with the machine's PLC. This ensures that any deviation from set parameters is immediately flagged, halting the process if necessary. This feature is vital for maintaining product quality in operations such as oil plug pressing or impeller shaft assembly. Window settings for load versus displacement. Via display, operators can set and adjust load versus displacement window settings directly through the display. This flexibility ensures that the press can be quickly configured for different components, whether it's an oil plug, water seal, or impeller shaft, ensuring consistent production without manual intervention. Evaluation and monitoring through display. The system evaluates load versus displacement results in real time, providing immediate feedback on whether the press operation was successful or if any deviations occurred. This is critical for detecting defects early in the process, especially for sensitive components like oil seals and water seals, where incorrect pressing can lead to leaks or failures. Data storage in PLC and sharing with MES. The data from each press cycle is stored in the PLC and communicated with the Manufacturing Execution System, MES, for further analysis and traceability. The MES system acknowledges the completion of a successful press operation before allowing the next cycle to start, ensuring traceability and quality control across the production line. Data search facility on display. Operators can search for historical data on the display, enabling them to review past operations and diagnose any issues that may have arisen. This feature is crucial for continuous process improvement and ensuring that each pressing operation meets stringent automotive quality standards. Integration with PLC for part number tracking. A scanner integrated with the PLC allows pressing data to be stored against the specific part number. This enables traceability, ensuring that every oil plug, seal, or shaft is pressed according to its exact specifications, and that data for each component is available for review. Mechanical stopper for safety. All hydraulic presses are equipped with a mechanical stopper to ensure operator safety and prevent overpressing, protecting both the equipment and components during critical operations such as impeller shaft or water seal pressing. Automating hydraulic presses for oil plug, oil seal, impeller shaft, and water seal pressing in the automotive industry enhances precision, consistency, and traceability. By integrating load cells, LVDT systems, data storage, and PLC communication, manufacturers can achieve optimal performance while ensuring compliance with stringent automotive standards. This level of automation improves productivity, reduces errors, and maintains high-quality output essential for modern automotive manufacturing processes.